Hello everyone, welcome back to the channel. In today's video, we are going to talk about one of the most powerful and widely used machine learning algorithm, that is supervised support vector machine. It means in the slide we can see that SVM is basically used for both classification and regression task. So if you are talking about SVM, so it is very clear and symmetric algorithm. So in this video, we will discuss about classification and regression tasks, and by the end of this video, you will clearly understand what is SVM is, how it works, why it's so powerful, and where it is used in real time or real life examples. So let's start from the basics. What is support vector machine? Like we are talking about SVM, it means it is a supervised machine learning algorithm. Supervised means we train the model using labeled data. For example, email labeled as spam or not spam, medical data labeled as disease or no disease, student data labeled as pass or fail. The main goal of SVM is very simple. It is basically used to find the best possible boundary that separates the data into different classes. So this boundary is called as a hyperplane. In 2D, a simple line. In 3D, it's kind of a plane. As you can see, this is called a hyperplane in 2D and 3D form. So in higher dimension, that is called as a hyperplane. Now we are talking about classification versus regression in SVM. So SVM for classification. Let's talk about classification first. In classification, the output is categorical. For an example, cat versus dog, fraud versus non-fraud, humor that is begin or malignant. That is called, in the slide we can see two groups of point, and SVM tries to draw a line that separates them. But here's the important part. SVM doesn't draw any random line. It draw the best possible line. That is more important feature of SVM. So SVM is for regression. Now let's talk about regression. Regression means the output is continuous value. Example, house price prediction, temperature prediction, stock market forecasting. So in support vector regression, SVM tries to fit a line but allow some error within a margin. Only important data points influence the model. This makes SVM regression very robust to noise. So that is the core idea of SVM. It's all about maximum margin. Now, this is the heart of SVM. What is margin? Now, we are talking about margin. The margin is the actual distance between the hyperplane and the nearest data point from each classes. As you can see, these are the data points, and we are talking about the margin between the hyperplane. Those nearest data points are called as a support vector. These are the support vectors. These are the nearest data points. So SVM always tries to maximize the margin. Why it is important? Just because of a large margin means better generalization. So the model becomes less sensitive to noise. Overfitting is reduced. Simple example we can say that is the imagination of two groups of students. One group passed. We are talking about one group passed and one group is failed. So you can draw many lines between them. But SVM asks which line keeps the margin distance from both groups. That line is chosen as the final decision boundary. So this is what makes SVM very stable and reliable. Now the point is, why is SVM is so powerful? So it works well in high dimensional data, that is called 3D dimension. Now SVM perform extremely well when number of features is large, data is complex. That's why SVM is popular in image processing, text classification, and bioinformatics. Now we are talking about kernel tricks. What if data is not linearly separable? No problem. SVM uses something called the kernel trick. That is called kernel trick function or kernel generalization function. That is the popular kernels like as a linear, polynomial, RBF, and sigmoid. These are the kernel function classification. So kernel trick transform data into a higher dimension where separation becomes easy without actually computing that dimension. This is a pure mathematical magic. So what are the real world applications? So SVM is used in many real world systems. We can say facial recognition, email spam filtering, medical diagnosis, handwriting recognition, intrusion detection system, financial forecasting. That's why SVM is very widely used in research and industry in today's era. So now we conclude this video. SVM is a supervised machine learning algorithm that is used for classification and regression both, and it finds an optimal hyperplane. So it maximizes the margin and it uses kernel tricks for complex data. So if you want a model that is powerful, mathematically strong and reliable, so SVM is an excellent choice. I hope you like this video. If you like this video, please subscribe my channel too. So thanks for watching.